The next chapter is called neural networks or simply neural nets. The basic idea is to replicate how human brain works. And human brain takes in input from external sources and then it goes through neurons that try to interpret the data that is coming in through our sensory organs, and then it generates an output that is intelligible to the human being. So this process is replicated in machine learning context, and therefore it is called neural net because it mimics the processing of human brain. The basic idea is to combine input from data set. Okay, so that will be like the sensory observations that human beings make through their sensory organs. Okay, and then you process, and that is there are some coefficients that are used to tweak the information that comes in, and then you produce an output, which is the classification in the case of binary or nominal target, or a prediction in case of interval target. So to look at neural network in a kind of a schematic diagram, this is what this will look like. And a neural network consists of nodes in layers, and then the nodes are connected with arrows. So we have a layer of nodes here on the leftmost side, and that's called the input layer. Okay, so here is where you get input coming into the system. And on the far end, we have the output layer where we have the classification or prediction in case of interval target, or classification in the case of classification class output. Okay. Then in between there are a bunch of layers. These are called hidden layers, and you can have as many hidden layers as you want, but more hidden layers, it makes the network more complicated. So typically the default is just one layer. Okay, one layer with a certain number of nodes in them. So here you will have on the input side, you will have one node for each predictor. So for each x variable, you have a node. Then at the far end, if you have interval target, we have just one node. If it is a class target, you will have one node for each class. So in the case of binary target, you will have two nodes, one for the event target equal to 1 and one for non-event target equal to 0. And in the hidden layer, how many nodes you want to have is really up to us. It is a tuning parameter, so you may want to try different numbers, 3, 4, 5, and then depending upon how well the model predicts the validation set, you make a selection. So neural network has multiple layers. So we have input layer, that is our observations. We have hidden layers, and then we have the output layer, which represents our target. Now the nodes and the arrows that we have are assigned some weights. So initially you assign some weights in a kind of a random fashion, and then the neural network goes through the calculations in an iterative process and fine-tunes those weights. So these weights, the coefficients, are updated or corrected in an iterative fashion. So bias, and these are called bias and weights, and we will talk about that next. Okay, so let's take a simple example to understand the network. Suppose we have a data set that has only 6 observations, and there are 2 predictor variables. The fat score and a salt score for some food item. Okay. For cheese, I guess, and the fat content is converted into a standardized score, and the salt content is standardized into a score. And for each observation, we have a target value, whether the cheese was of acceptable quality in terms of flavor, etc., or not acceptable, which is coded as 0. Okay. So now we suppose we have a one hidden layer neural network. So this is what it will look like. So you'll have one node for each input predictor. So that's your input layer. Since there are two predictors, fat score and salt score, we have two nodes. And then at the other end, we have the output layer, where this is a classification problem, whether it was acceptable or not. Okay, so dislike being not acceptable, like being acceptable. So you have two nodes at the far end, and then we are using only one hidden layer, and we have selected 3 nodes for the hidden layer. Again, how many nodes we want to have in the hidden layer is a tuning parameter that we have to decide. We try different values, whereas the number of nodes in the input layer is not something that we decide, at least within the context of the model, which is what the number of each predictor variable will have one node. And again, at the output layer, we don't have a choice. It's just the number of, in case of nominal target, each possible value of the target, and if it is an interval target, there is just one. So on the hidden layer, the number of nodes is up to us, and we can try different values and select the one that gives us the best model.